Anil Kumar, Faculty of Digital Electronics. Let us try to understand decoder circuit. Sir, in the previous lecture, we have seen encoder and even priority encoder. Now let us try to understand decoder. Sir, when I thought demultiplexer, combinational circuit, one of the combinational circuit demultiplexer, I said one point that the internal hardware of demultiplexer and decoder both are same. So now even if we understand demultiplexer circuit, here the decoder circuit analysis is also very important, very easy. And now this is very important circuit, even easy to understand. Sir, as like we learned multiplexer and demultiplexer both are exactly opposite to each other. Even encoder and decoder both are exactly opposite to each other. The statement which I gave when we learn encoder circuit, it is a combinational circuit. It is used to convert all other codes to binary codes. Here the exactly opposite circuit is a decoder. Here decoder is used to convert all binary codes to all other codes, we can say that. Now let us make a heading. Take down decoder. First point, let me write it as it is a combinational circuit. It is a combinational circuit. The moment when I say combinational, for every circuit, every lecture, I am teaching these basics for 1 or 2 minutes, because it is very important to understand before going to see what is combinational circuit, what is decoder circuit and all. Sir, that is the important thing. So we must be able to understand the basics before learning the subject. Sir, decoder is a combinational circuit. The moment when I say combinational, its output is only depends on its present inputs, and it should not have any memory, it should not have any kind of feedback, and it should not contain any synchronization process. So that is the thing of combinational circuits. Even all these things applicable for even decoder also. Sir, here decoder, the main ultimate aim of decoder is to convert binary codes to all other codes, which are, we can say simply 3 to 8 decoder, we can say 2 to 4 decoder, and now we can say 4 to 16 decoder, something like that. And now here we can use this decoder circuit used for chip select process in digital circuits design. When we are making digital circuits design, internal hardware, we will use decoder circuit for chip select. That may be one of the interview question or basic IS prelims question. Let us try to understand. Sir, this is the thing. And now if you see the basic circuit, let us see 2 to 4 decoder. Make heading 2 to 4 decoder. 2 into 4 decoder. Let us try to understand. Sir, the name itself indicates it is having 2 to 4 decoder. Can you please just tell me how many number of inputs are there? Here number of inputs, we can say here 2 to 4. Can you please just tell me 2 inputs are there? And now how many number of outputs are there? We can say 4 outputs are there. Sir, can you please just tell me what is the circuit diagram for this 2 to 4 decoder? Here the circuit diagram is we can say circuit diagram is like this. Here we have 2 to 4 decoder, 2 into 4 decoder, 2 into 4 decoder. The two inputs are, we can say, I want to write I0 and I1. Can you please just tell me A and B? A and B. And now outputs are, we can say, Y0, Y1, and now here Y2, and finally Y3. Sir, for encode, we can say multiplexer, demultiplexer, we used select lines or control lines to make operation or to transfer the data from input to output. Whereas coming to encoder and decoder, even priority encoder, to transfer the data from input to output, we use a device called a pin called enable. E for enable. Enable pin we are using. And now this is the block diagram. Based upon this block diagram, let us try to construct truth table and its logical expression. Please note the circuit diagram and now make a heading. Here truth table. Third one is truth table. Sir, here the truth table, number of inputs are 2 and outputs are 4, we can say. Sir, here can you please just tell me A, B are the inputs and now outputs are, we can say Y0, Y1, Y2 and Y3 are the inputs. Outputs we can say. The left one is enable input. I will take this enable pin here. Sir, here this is the truth table. Let us try to analyze. Suppose if enable pin is input, which means suppose if enable pin is 0, automatically this enable pin is 0 means here there is no established connection between input and output. Because there is no established connection between input and output, there is no data transfer from input to output. So that we can say here 0 inputs A, B 0 and outputs Y0, Y1, Y2, Y3 all are zeros. Sir, but for better understanding, I want to write here the truth table as like this. Here for better understanding sake, I want to write it as this is Y0, Y1, Y2, Y3. Why sir, why you are writing like this? This is exactly opposite I am writing to the encoder. Encoder we took Y0, Y1, Y2, Y3 and I am taking here exactly opposite Y0, Y1, Y2, Y3 for better understanding. Sir, here enable input, the moment when I make enable input is equal to 1, automatically here the applying input is 0, 0, we can say that. The moment when I apply inputs both are 0, we can say Y3 0, Y2 0, Y1 0 and output is 1. And now this output is a 1 at Y0. And now here enable pin is 1 and now the input is 0, 1, binary data input 0 is 1 and now the output data will be 0, 0 and Y1 will be select and all other are zeros. And coming to enable input 1, here 1, 0 input we are applying as a binary data and now this will be Y3 0, Y2 1 and all remaining are zeros. And coming to enable input 1, here these two ones and now we can say Y3 1 and remaining Y2, Y0, Y1 will be 0. Sir, if you see this truth table, based upon this truth table, let us try to write the logical expression. Sir, here let me write the logical expression and based upon that logical expressions, we have few analyses. Sir, here two inputs, we can say A, B and this is enable input and now this is 2 to 4 decoder. This is 2 to 4 decoder, outputs Y0, Y1, Y2, Y3. Now can you please just tell me what is the output of Y0? This one. The moment when output Y0 is enabled, which means, can you please just tell me the corresponding inputs are here? These are the two inputs. What are those two inputs? We can say Y0 equal to A0, B0. Can I say that A bar and then B bar? Yes. A bar, B bar. And now I want to write here for enable input also. A bar, B bar, E also I want to write. Sir, here enable input, no need of putting enable, but just for the sake of understanding I am putting, even the original expression is A bar into B bar. And now coming to Y1 output. What is the Y1 output, sir? Here output Y1 is 1 when inputs are A0, B is 1, which means Y1 equal to A bar B and now enable input E. And now coming to Y2, can I say that this is Y2? Yes, sir. And now inputs are here we can say A into B bar, enable input is E. And now coming to Y3, here both inputs are ones, so that I want to call it as A, B into E. This is what the output. Sir, this is the output we can say. And now can you please just tell me, suppose if I remove, no need of writing enable input, I told. This is the circuit, sir, decoder circuit. This is enough. And I am telling you, nobody can ask a question based upon decoder. This is the good news for us. But only thing is, how many number of decoders are required to implement a half adder? How many number of decoders are required to implement half subtractor? How many number of 3 to 8 decoders and other gates are required to implement a full adder and full subtractor? That is the most important bit in gate point of view and even PSU point of view. If you want to go and verify, check the questions, you will find this question in every 2 years papers. So please try to understand. Suppose to implement half adder, sir, this is the 2 to 4 decoder. Sir, based upon this output A bar, B bar, A bar B, A into B bar, A B, I want to construct. Here the question is asking how many construction, we can say construction of half adder using decoder. This is also one of the separate concept, but I am covering here for better understanding. Sir, can you please just tell me half adder is having how many outputs? We can say first output is sum output and the second output is we can say carry output. Can you please just tell me what is the sum outputs are here? A bar B plus A into B bar. Can we say that this is what A XOR B? Yes, sir. This is the half adder and carry output we can say AB. And now can you please just tell me what is the half subtractor output? Half subtractor we can say we will be having 2 outputs. We can say that half subtractor, for half subtractor output we can say 2 outputs. Here first one is we can say difference and second one is borrow. Sir, difference output we can say A XOR B and borrow output we can say A bar B. So this is what, suppose if we can make difference between A minus B, we will be getting output A bar B. Suppose if you make a difference B minus A, we will be getting output B bar A. That is what we have seen in half adder and half subtractor. Now let us try to prove even these output equations, half adder and full adder output equations with the help of decoder. Sir, here if you see the output of decoder, suppose if I can take output of Y1 and Y2, if I can connect one, we can say if I can connect one OR gate, we can say OR gate. If I can connect one OR gate, what will happen, sir? Here Y1, here we can say x equal to y1 plus y2 is the output. Here x equal to, what is the y1? A bar b plus y2 is a into b bar. Can I write x equal to a XOR b? Yes sir. Is it not the output of half adder? Yes sir. This is the output of half adder, we can say sum output. Sum output. What is the carry output sir? Can we take directly output from y3? Yes sir. Here z equal to y3, we can say a into b. So this is what? This is the implementation. How many number of decoders and other gates are required to implement half adder sir? Here we can say that one decoder, let me write like this, one decoder plus one, we can say OR gate. OR gate is needed to implement half adder. This is the way of understanding. And can you please just tell me here, half subtractor implementation also very easy. Here sir, half adder, and if you see half subtractor, the same OR gate is required, and the output can be taken from here a into b. We can say this is the borrow output. We can say a bar b. And now here, even to implement half subtractor also, we can say for half subtractor we need one decoder plus one OR gate to implement half subtractor. This is the way of understanding the decoder. Sir, thanks for watching. We could able to complete most of the combinational circuits. The leftover is serial adder, parallel adder and carry look ahead adder. We will see all those three adders also, and after completion of these three circuits we will move on to the third unit called sequential circuits. Thanks for watching and thanks for supporting. Please do subscribe and share to your friends.